In this week's video, we will be discussing some problems that arise in AI safety research, and in particular in work done under the broader umbrella of AI alignment research, technical AI alignment. The week after, we will see some proposals that pertain to work in AI governance. Now, as I've said before, we have concluded the broader philosophical conceptual discussion in order to frame AI risk and to understand the alignment problem and why it is such a difficult problem. From the previous week, where we talked about moral philosophy, moral obligations towards the future and future people, and this idea or movement of long-termism, you may now be at a point of wondering, sure, if there is a moral responsibility towards the future, what are the conditions under which we at the present can contribute to making the future go well? What is the kind of work that researchers are engaging with already? And what would be some concrete problems to dive deeper into? What would be some agendas to explore? And in general, what are the next steps? Again, assuming you're on board with the idea that we should work towards ensuring a flourishing future for humanity. So these 2 weeks are devoted to exploring that path of working towards a good future for humanity, first from technical AI safety, and then from AI governance. So, starting with this paper, Concrete Problems in AI Safety, as you may have seen already, it's a relatively long paper which may have some terms you have not encountered before. You may want to look up some terms. I'm purposefully choosing a more challenging paper exactly to give you a good sense of what kind of work are AI safety researchers interested in and what does it look like. One, because you may be genuinely interested in finding out how do we tackle a very difficult problem like this, the AI alignment problem. And secondly, because many of you may already have some skills that would enable you to work on this problem directly or find some sub problems that you find more interesting and specialize in them and make some progress in them. So this is a challenge, but also a really good opportunity to look at the problems closely and see what you really think about them and try to really understand them, and if needed, criticize them and see how you could make some progress here. So the paper begins again with the difficulty of the problems in machine learning. And as you already know, the progress of machine learning has been exciting. It can transform various fields, but we have not solved the problem of how to install goals into a system, how to make a system behave according to the goals of its developer, and how to make sure that there's no unintended or harmful behavior emerging out of these machine learning systems. And the one first term that you'll see here is objective. Objective, we use it interchangeably as goal as value, as you have seen before. And so another way to pose this question is, how do we ensure that these machine learning systems have the right objectives or acquire the right objectives through their learning process? Because as you remember, these are systems that learn how to pursue a goal rather than being programmed to pursue a specific goal. And you've already read a lot about accidents, normal accidents, remember from earlier in this course, how things could go wrong. I think you have plenty of material already. If you need to return to it, to refresh your memory, how we could have many extreme scenarios of really, really negative outcomes for society and for humanity. So this is not the goal of this paper. Rather, we want to see how this control problem, technical AI alignment problem, translates into specific research questions and how these problems can be framed and how can they be understood. So this is very important for you to make sure that you are able to say in simple words what these problems are. And so we start. One problem that you may have already developed some intuitions about is, how do we make sure that there are no negative side effects? So assuming we're training a model to pursue a certain goal, is there a way to reliably make the model pursue this goal without doing also something else that is harmful, is unintended, is bad? It is a side effect. It's not the main thing that the model is doing, yet nevertheless, we would really, really not want the model to do this and get to that goal. Now, second, avoid reward hacking. What does this mean? This is a new term. Reward hacking is about the model's ability to be evaluated by the designer, by the developer, by the human evaluator. And so when it's completing a task, it may be getting reward. The model gets some kind of reward in reinforcement learning settings. If you look up the term, it's a kind of training setup for machine learning models. And so this problem concerns, how do we ensure that the model does not do something so that the human evaluator rewards the model for its actions, even though they're not the actions that the human developer originally wanted the model to do. So you understand how this could be a problem. Imagine a little child managing to receive, let's say, candy, even though it's not behaving according to how their parents want the child to behave. So, for example, the parents are trying to teach the child to say thank you when appropriate, and the child finds a way to get the parents to reward it, but not for saying thank you, for doing something else that is not what the parents want. Scalable oversight. What does this mean? Another term that's good to know. It means that as we go to more and more capable models, bigger models, we are able, as human evaluators, to know that the model is doing the right thing, even though we may not have sufficient information to evaluate the model, because, for example, the task the model is pursuing is very, very difficult. And you've seen that in previous videos and papers that we've had. What do we do when, for example, the model has to solve a very, very complex problem that as humans, our cognitive abilities would be too limited, or it would take us too much time, or it would be too arduous an activity for us to make sure that every little step of the process is correct. So this is a big challenge here to ensure that the model is doing the right thing, even though we are limited exactly because of our human cognitive abilities. Another problem is safe exploration. How do we make sure that our model doesn't try to explore other options, to pursue other paths as it's pursuing its goal? And as it's doing that, again, it gets us to some negative side effects. So, for example, here you see maybe having a robot which is trying to mop a floor, and it doesn't intend to put the wet mop on the electrical outlet, but somehow it ends up doing that, and this is a harmful outcome. Well, it's not clearly misaligned here. It could lead to a disaster just because it explored the space of options that it had around. And lastly, this idea of robustness to distributional shift. What is robustness? What does it mean to be robust? And you can think about it in terms of humans too. What does it mean to have a robust personality? It means that regardless of the environment you are in, your behavior is predictable. It means that you're not particularly sensitive to whether you're hanging out with your friends or your parents or a different group. Your personality is pretty much the same. You don't become drastically different just because you're around other people, for example, or just because you're around in a different environment. So that's what robustness to distributional shift means. It's pretty simple, actually. It just means that the model behaves, again, reliably. We can predict the behavior on the model regardless of the training environment that it's put in. And in the rest of the paper, you can go and read in more detail what these points mean, but I think so far I have given you a good idea of why we might be interested in these problems. What are they exactly? But it's really worth taking some time to process them on your own, to really understand why are these difficult problems. And maybe you'll see that you've observed them with other agents around you in your environment. Or maybe in certain ways you have already thought about them and you just realize that these are problems that concern behavior, being able to model behavior, to predict behavior, to explain behavior. And that makes them so challenging and exciting and complicated, and at the end very difficult, and some of the most complex problems for this generation of research scientists to solve.